Okay, today we're going to talk about Congruent Polygons 5.2. What I want you to do is start out on page 128 of your student journal and complete exploration number 1. And then if you're just kind of waiting around, you can start on exploration number 2. That'll be our next piece. Given two congruent triangles, how can rigid motions map one to another? Okay, all right. What do you guys think? Translation or transformations, which are rigid motions? This one a rigid motion. How about here? How about a rotation? How about a dilation? No, remember rigid motion, okay, corresponding parts of the image and pre-image map onto each other. They're congruent. Corresponding images or shapes or parts, sides and angles have to be congruent. In a dilation, they're not congruent. All right. Very good. So, when I'm looking at these, does ABC and DEF, do they look like rigid motion or rigid motions there? They look congruent? Yeah. Do these two look congruent? Yeah. Okay. So what I want you to do is I want you to describe the composition of rigid motions or the different transformations you have to do to get ABC to DEF. Okay. Try that for A and B, and then on the next page, on page 129, there's a couple more. I'm really probably only going to go through these two, but you can try those other two as well. Okay? All right, the first one. What do we have to do? Isaac? Okay, reflect it over y equals 0, which is our x-axis. Okay? And then what? Okay, and then translate x plus 3. Okay. And is that it? So y doesn't change. Very good. All right. Okay. How about here? No one got that one? Yeah. Rotate 180 degrees about. So did you go about the origin? Okay. All right. So good. We could double check that, right? So A would have to go to D, and if we were to connect those 2 points, it would be a 180 degree rotation if it's a straight line there. And in this case, oops, those form a straight line. Okay, kind of go through the same process here and here. The line's are already drawn for it. Okay, you could also use your properties. Right? It didn't matter which way you rotated it, right? 180 one way is the same as 180 the other. Yeah. Yep, you could. Okay, very good. Hey, I'm not going to do the other part of the exploration, but what I want to do is make sure that we understand congruence. Take a look at page 130 of your student journal. I want you to just read through the properties of congruence. Okay, read through Theorem 5.3 and Theorem 5.4 real quick. Make any notes you need there. Okay, those properties should look very familiar, right? And we've talked about the reflexive property before. Now we're applying it to triangles. Same thing with symmetric and transitive. Reflexive says a triangle is congruent to itself. Symmetric says if ABC is to DEF, then you can just switch those around. Say DEF is equal congruent to ABC. And then transitive was that one that kind of was like substitution. If ABC is congruent to DEF and DEF to JKL, then ABC is congruent to JKL. Okay? So when we're talking about congruence, we're using that transitive property. All right? This is kind of the new one. Even though we've used it a lot this year, we're actually putting a name to it. The third angles theorem says, hey, if two of our angles are congruent to two of the angles of another triangle, then the third one is also congruent. Okay? Tell your neighbor how you know that has to be the case. Why does C have to be congruent to F then? Okay, why do they have to be congruent? Jeremiah? Okay, but like why? Jordan? Yeah, they have to add up to 180. So if you have a sum here, say of 100, and that means this is 100, that means there's only 80 left, and it has to all go to one angle. Okay? Oh, not cute. All right, little mood music for our math class. Good stuff. Okay, go ahead and turn the page there. I want you to work on page 1 and 2 on page 131. Okay, do your best right there. I'm looking more, it says identify all pairs of congruent corresponding parts. That's really what I'm looking for. When it says write another congruent statement, it's just saying, hey, you can switch the letters around and it would still be the same thing. I'm more concerned about the first part there. Okay, I'm not as concerned about the second statement. All right, 1 and 2. All right, so if you're looking at your paper, just so you know, you should have 6 different things written down for number 1. All right, how many have all 6? Oh, all right, 6 different things, 6 different parts of those triangles that are congruent. Here are our 6 for number 1. By the way, that also means how many should you have for number 2? You should have 8. Here are the 6 for number 1. Okay, and if you want to rewrite the name in a different way, it would be R. You could use that as an example. But, hey, angle P is congruent to angle S. That's given. Angle Q congruent to angle T, also given. Angle R congruent to angle U, also given. Which, if the angles, in this case, or excuse me, if the triangles are congruent, that also means our corresponding sides are congruent. So PQ to ST. So if we wanted to, we could actually mark these. Okay, PQ to ST, and QR to TU, and RP to US. All right. Very good. All right, tell your neighbor what you got on number 2 there. All right, there's number 2. Angle A to angle E, angle B to angle F, angle C to angle G, angle D is congruent to angle H, then AB to EF, BC to FG, CD to GH, and DA to HE. Hey, is this tough? No, this is pretty easy. You're just identifying congruent and corresponding parts. But what happens is you have to do that when you put it in application into little tougher problems. So the problems are going to get gradually more difficult. Okay? Try number 3 and 4 there. Using the information they've given and the congruent corresponding pieces that we just talked about, you can try to find X there. All right, go ahead and tell your neighbor what you got. What's X equal and Y equal number 3? Two x minus 20 equals what? This angle is equal to that angle there. Notice Y is in the middle position here and S is in the middle position. Therefore, they're congruent corresponding pieces. Therefore, that equals that. 2x equals 10. X is 2x equals 50. Excuse me. X is 25. How many got it? All right. Y, notice XZ. So XZ, first and last position. And then TS. Oh, TS. Oh, but they're congruent pieces, so we're okay there. That matches up here. So we have 15 equals 3y plus 9. So what's 3y equal? Dude. And so y is 2. Okay. Hey, number 4. What'd you guys get for x? 6. What'd you get for y? 10. 6 and 10. Okay. So on this one, 8x plus 60 equals 108, and 3y minus x equals 62. Okay, any questions there? All right, turn the page, please. Page 132. Show they're congruent. A little tougher now. Show they're congruent. Explain why. Work together. By the way, the easiest way to show they're congruent is to write a 2-column proof. It's the best way to stay organized. Start out with your given info. All right, guys, throughout this chapter, we're going to get into more ways to prove that these are congruent. But right now, what you know about shapes, the best way to prove they're congruent is to prove that corresponding parts are congruent. So in a triangle, you would have to be able to state that all corresponding parts are congruent. Well, notice they give you A is congruent to C, DA is congruent to DC, CB is congruent to AB, all by markings. We also know that DB is congruent to DB by, it's called the reflexive property. Okay, so we'll end up talking about that now. But we don't have to spend too much time on it right now because we can just say it's the same angle. All right, here's my written up proof. AB is congruent to BC, AD to CD, our angle's congruent, theirs are given. Notice ADC is a right angle. You have to state that, okay? We know that this angle right here, AD, not ADC, that should be BDC. Oh, BDC is a right angle, okay? Based on supplementary angles, and then you have to state that these two angles are congruent based upon all right angles being congruent. All right? And then DBA is congruent to DBC by the third angles theorem that we talked about today. If two angles are congruent, then the third is congruent. And since corresponding parts are congruent, the two triangles are congruent. Okay. The number 6 is a lot more direct, or a little more direct there. We know that since all the given statements, everything's marked as congruent, you can choose given, then say that your right angles are congruent because all right angles are congruent. And then the two figures are congruent because corresponding parts are congruent. All right. Good? Take that out when I'm talking, please. Take that out when I'm talking. Come on, guys. Yeah? There could be multiple ways. If you have another way, you can talk to me about it. But right now, really, based on what you know, you're having to use all corresponding parts are congruent. Okay, like if you know other info, then you can do it. Okay? All right. Hey, while I'm handing out today's assignment, I want you to take a look at number 7 and 8. Okay? All right, number 7 and 8. Hey, what is angle 1 here? Dude. Alex? It would be 33. How come?
Because angle ABC.
Mm-hmm.
No, the AC is congruent to that.
Okay, so these two are congruent. We know that this one's congruent to that, 33. This one's congruent to that, that's also 33. Okay? Based on their markings there. We got 33. How about angle 1 here? It's congruent to this one. This one happens using the triangle angle sum. That gives you 46, which makes this 46. All right. Very good. Okay, you have your assignment. If you have questions, make sure you talk to me about them.